Hello everyone, in today's video I'll show you the preparation of a chemiluminescent compound which is known as lucygenin. The first step is the preparation of N-phenylanthranilic acid, also known as phenamic acid. In a 250 ml beaker, 10 grams of orthochlorobenzoic acid was weighed out, which was proceeded by measuring on a watch glass a quarter of a gram of copper to oxide, which is gonna act as a catalyst. Then, 39 ml of aniline, which equates to around 40 grams, due to a density close to 1, was poured, definitely without any spills, into a graduated cylinder. Then, the aperture which was gonna be used for the experiment was set up. A 250 ml free-neck round-bottom flask was secured with a clamp on a lap stand and then put into a heating mantle. Then it was tilted due to my fume hood's limited height. A Liebig condenser was then inserted into the middle neck, while the other two necks were sealed. As you can see, I didn't have a second 14x20 glass stopper, so I used a bigger one along with an adapter. Through the adapter, 10 grams of anhydrous potassium carbonate were then added, which required a bit of jamming with a stirring rod due to small clumps of the reagent forming due to absorption of the water in the air. Because of this issue, when it came to adding the 2-chlorobenzoic acid, I changed my mind and took out the Liebig and poured the acid into the flask through a funnel, which was preceded by the cupric oxide. The contents inside were roughly mixed using a glass stir rod. The condenser is mounted again. Slightly discolored aniline is added through the adapter, which is then stoppered. Hoses coming out from the pump placed in a bucket of room temperature water were then connected and the circulation was turned on, which was followed by applying power to the heating mantle. Once the mixture began refluxing, the further heating was continued for 2 hours to bring the reaction to completion. This reaction is a classic example of an N-alkylation. The electron pair of aniline's nitrogen attacks the electron-deficient carbon adjacent to the chlorine, which after expelling the halide as an anion, forms an intermediate which undergoes deprotonation with potassium carbonate acting as a base. The copper oxide mainly acts here as a catalyst. I also noticed the white vapors in the condenser, which I thought looked pretty cool. After the 2 hours have passed, the mixture is cooled, the condenser is drained, and then the contents of the flask are quenched using 150 ml of distilled water, which is not shown. Some additional H2O was also added to wash out the condenser. A separatory funnel was placed in a lab stand, and after checking if the tap is closed, the reaction mixture is transferred to it. The flask is further washed with a small amount of water. It is then extracted with 3 50 ml portions of diethyl ether in order to remove the unreacted aniline. This step can also be substituted by a steam distillation. The aqueous phase is then transferred into a 600 ml beaker to which 5 grams of activated charcoal is added in order to remove some of the coloration. The mixture is then boiled for 15 minutes and then filtered hot through a coffee filter. To the filtered 10 ml of 38% concentrated hydrochloric acid mixed with 20 ml of water is added, which precipitates the free acid, which is subsequently obtained through a vacuum filtration on a Wagner funnel with a few washings with small amounts of water. The yield was not measured because I was lazy, and the next step doesn't require the exact amount anyway. The product is dried in free air or in a vacuum desiccator. The next step is the synthesis of acridone, which is gonna be achieved via the dehydration of the product obtained in the previous step, accompanied by the formation of a ring, forming the acridine skeleton. The 10 to 13 grams of N-phenylanthranilic acid is dissolved in around 25 ml of concentrated sulfuric acid. In my case, I use drain cleaner acid, which doesn't contain any organic junk, which, if present, could cause impurities to be introduced. It is then heated on a water bath for 1 hour. The hot solution is then very carefully poured into 200 ml of boiling water. The best way to carry this out is to get a tall-walled 1 liter beaker and wear long rubber gloves and, in the best case, a face shield or a fume hood sash to protect you from any splashing which may occur. The yellow suspension is then boiled for a few minutes in order to hydrolyze any sulfonated acridone. After this, it is filtered through a coffee filter and the wet solid is added to a sodium carbonate solution composed of 8 grams of the carbonate and 100 ml of water and then heated for 5 minutes. After that, the acridone is vacuum filtered and vacuum desiccated. It is advisable to purify this solid by the means of action of some solvent on it. However, a recrystallization is very hard to do because this product is hardly soluble in anything. I personally tried a Soxhlet extraction using acetone as a solvent with the hopes of getting the acridone into solution. This, however, proved to be basically impossible due to the fact that even after countless hours of running the setup, only a small amount of the compound got carried over into the flask, which contents also turned a reddish color. I decided to stop with the hopes that at the very least maybe the impurities got washed out and inside the extractor I would be left with reasonably pure acridone. Some sources also claim that said process is possible using ethanol or DMF ethanol mixtures. Now onto the N-methylation of this product. I actually don't have any footage of the reaction itself, however I'm gonna run you through it, while some photos from the preparation of the methylating agent used are gonna be shown. The substance I am talking about is of course methyl iodide, which was synthesized via the red phosphorus iodine pathway. In a 100 ml round bottom flask, 4.1 grams of acridone is dissolved in a hot ethanolic solution of 1.3 grams of potassium hydroxide in 50 ml of the alcohol. This may not result in a clear solution, as it is often mentioned in the literature, however proceeding anyways, with it still being murky, seems to yield good results anyway. The mixture is heated on a water bath and ethanol is evaporated. To this, 50 ml of dimethylformamide is added as a solvent and 3.5 grams of methyl iodide is quickly added in order to avoid unnecessary evaporation. This reaction is quite similar to the phenamic acid synthesis, only here we are changing out the solvent for DMF, which is suited for this kind of reaction for a few reasons, but mainly due to its ability to dissolve the reagents, and also being a polar aprotic solvent, it won't proteinate the amine. After this, the flask is heated on a water bath for around 10 minutes, and when this is finished, the reaction mixture is poured into 100 ml of water in a 300 ml beaker. Beautiful, bright yellow needles of N-methyl acridone crystallize and are then filtered. Let's now proceed into basically the final step of this synthesis, preparation of the bis acridone compound via a metal reduction. In a 250 ml flask with a condenser attached, 1 gram of N-methyl acridone, 50 ml of ethanol, and 10 ml of concentrated HCl are brought to a boil. Through the course of 15 minutes, 3.2 grams of powdered zinc is added in small portions through the top of the condenser, and then the flask is heated for half an hour. After this, 100 ml of water is added, yielding a green precipitate of the bis acridone compound, which is filtered. The wet solid is added to 60 ml of 6% nitric acid and then heated on a water bath for a quarter of an hour. The resulting mixture is cooled, and after standing for a few hours, big orange crystals of the lucygenin dinitrate, which kinda remind me of a sparkly grated carrot, precipitate and are filtered. The yield should be around 0.6 to 0.9 grams. Now onto the most spectacular part, the chemiluminescence. We prepare two solutions, one composed of 8 grams of sodium hydroxide in 70 ml of water and 5 ml of 1.5% hydrogen peroxide in 30 ml of ethanol, and the second one by dissolving 0.1 grams of lucygenin in 100 ml of water. I used about half of each solution for the demonstration. In a dark room, roughly equal volumetric amounts of the liquids are poured into one beaker. A weak, though definitely stronger than luminol, greenish glow can be observed. solution resulting from the reaction also exhibits fluorescence due to the presence of N-methylacridone due to the formation of it from the degradation which happens under the influence of peroxide in a basic environment. That was all for today. I am very sorry for the lack of footage and info in this video, however it was really difficult to film many shots in my old cramped lab, and also this synthesis was carried out nearly 2 years ago, so I may not recall some details about how the procedure went. I don't promise it, but I'm gonna try to make my next videos overall better in quality due to having more experience, knowledge and also more equipment and chemicals.